In this video, we will start section 5.3 to introduce the standard normal distribution. In the Introductory Statistics by OpenStax textbook, this is section 6.1, and the Introduction to Statistics Corequisite book by Lumen, this is module 6, the normal distribution, Introduction to the Standard Normal Distribution. We want to remind ourselves what we have learned about the z-score. The z-score is the number of standard deviations the value x lies away from the mean. The formula was x minus the mean divided by the standard deviation. We have two different situations. One is when we have a population, then the mean is mu and the standard deviation is sigma. When we have a sample, the mean is x bar and the standard deviation is s. And another way to use the z-score is to actually have the distance in standard deviations from the mean and find x. And the way we do that is we have the mean and we add z times the standard deviation. For example, if the mean is 5 and the standard deviation is 2, so mu is 5 and sigma is 2, or x bar is 5 and s is 2. The value 11 is 3 standard deviations above the mean, and that is because the z-score will be 11 minus 5 divided by 2. So that is 6 divided by 2, which is 3. 3 standard deviations above the mean. And positive means that you had a greater value and you are to the right of the mean. The value 1 is, let's find out, 1 minus 5 divided by 2, that will be negative 4 divided by 2, which is negative 2. So that is 2 standard deviations below the mean. And that will mean this will be to the left of the mean. So, if we are greater than the mean, then x minus the mean will be a positive quantity and we will have positive z-score. If we are below the mean, then we have a smaller value than the mean. X minus the mean in the numerator will be negative and we will end up with a negative z-score. Most distributions are not uniform, like we learned earlier, where everything is equally likely to occur. Most distributions are actually kind of bell-shaped and have the trend for the data to cluster around the mean, with very few values showing up too far from the center. And we have seen some examples. We have seen the binomial distribution of the students completing the homework on time. We have seen Syracuse daily temperatures in April of 1995. And this was in April of 2005. This is incorrect about the 1995 here. We saw this in one of our projects. And we see that we do have several of the values clustering around some measure of center, and then very few values going towards much lower or much higher than the center of the data. And in real life, there are other curves. During the COVID pandemic, we heard so often to flatten the curve. And basically what they were trying to do is to take a curve that has very low width, very small domain width, and expand it over time so that we have longer time to take care of less number of cases here. There is another normal distribution, is the distribution of male and female heights. This is also actually appears in nature as well. It will be a normal distribution for, let's say, the lengths of the beaks of woodpeckers. Most of them will tend to have a certain value very close to the mean and the median, and very few of them will have very short beaks or very long beaks. Here is another one, which is the relative frequency of central pressure in millibars during different storm categories, and this is an example that I took off the web. And remember that the measures of center, are the mean, the median, and the mode. And when we have a normal distribution, the normal distribution, which is the most popular one of the bell-shaped distributions, has the property that it is symmetric. And when it is symmetric distribution means that the mean, the median, and the mode will actually fall on the same value. And in these curves, they correspond to the value at the highest peak, the x value on the axis that has the highest peak. And that is the mode, and then the median and the mean fall there. The area under the curve is equal to 1 because we want this to be a PDF. So the whole area under the curve has to be equal to 1. And the empirical rule applies. We have seen the empirical rule in the previous chapter. It says that 68% of the data will be within 1 standard deviation from the mean. 95% of the data will be within 2 standard deviations from the mean, and 99.7% of the data will be within 3 standard deviations from the mean. These intervals have the mean in the center, and then I go left 1, 2, or 3 standard deviations, and right 1, 2, or 3 standard deviations. The points of inflection are at 1 standard deviation away from the mean, and what the inflection means is that the normal curve curves down around the mean in the middle of the distribution, and then curves up going away from the mean. So the points of inflection is when it starts curving down and it starts curving up. And the notation for a variable to follow a normal distribution is x tilde n parenthesis mu comma sigma. It's read as the variable x follows a normal distribution with mean mu and standard deviation sigma. So the first normal distribution is the distribution of the z-scores. It's called the standard normal distribution, and the z-scores are called the standardized scores. And it is a normal distribution of standardized values called the z-scores. The mean of the standard normal distribution is equal to 0 because a value x that is equal to the mean will make the numerator of the z-score x minus the mean equal to 0. The standard deviation is equal to 1 because when this distance x minus the mean is divided by the standard deviations, if you are 1 standard deviation away from the mean, then you will have a z-score equal to 1. So z is a variable that follows a normal distribution with mean 0 and standard deviation is equal to 1. And it looks like this. It is a bell-shaped curve. It is symmetric, so excuse my inaccuracies in my art. The highest point corresponds to the mode and also the median and also the mean, so that's a 0. And 99.7% of all the data is within 3 standard deviations from that mean, so I'm only going to do 3 tick marks to the right and 3 tick marks to the left, and that should cover almost all of the data that I could portray in a graph. Every tick mark is a standard deviation, 1, 2, or 3 to the right, and -1, -2, -3 to the left. And the label here is the z-scores. Z-scores do not have units, because the numerator, x minus the mean, is measured in the units of the variable, and the denominator, which is the standard deviation, is also measured in units of the variable. We will stop here for now, and then we will continue with a second video regarding the standard normal distribution.